Welcome everyone. Today we are looking at Topic 4 in your SS3 Physics series, Electromagnetic Waves. This is an advanced treatment of electromagnetic waves. This topic always appears in your objective questions. You must understand the properties, the spectrum, and the applications. Pay close attention. Let us begin. First, let me explain what electromagnetic waves are. Electromagnetic waves are waves that consist of oscillating electric and magnetic fields. They are transverse waves. They do not require a medium to travel. They can travel through a vacuum. They travel at the speed of light in a vacuum. The speed of light is approximately 3 times 10 to the power of 8 meters per second. Electromagnetic waves are produced by accelerating charges. They carry energy and momentum. They are fundamental to physics and technology. Understanding electromagnetic waves is essential for understanding light, communication, and many modern technologies. Let us now examine the properties of electromagnetic waves in detail. Now, let me explain the properties of electromagnetic waves. Electromagnetic waves have several important properties. First, they are transverse waves. The electric and magnetic fields oscillate perpendicular to the direction of propagation. Second, they do not require a medium. They can travel through a vacuum. Third, they travel at the speed of light. The speed is constant in a vacuum. Fourth, they can be reflected, refracted, diffracted, and interfere. They obey all the wave properties we studied in SS2. Fifth, they carry energy and momentum. They can exert pressure. Sixth, they are polarized. The electric field oscillates in a specific direction. Understanding these properties is essential for understanding electromagnetic wave behavior. Each property describes a different aspect of these waves. Now, let me explain the electromagnetic spectrum. The electromagnetic spectrum is the range of all electromagnetic waves. It is arranged according to wavelength and frequency. From longest wavelength to shortest wavelength, the spectrum includes radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Radio waves have the longest wavelength and the lowest frequency. Gamma rays have the shortest wavelength and the highest frequency. The speed of all electromagnetic waves is the same in a vacuum. As the wavelength decreases, the frequency increases. The energy also increases. This is because energy is proportional to frequency. Understanding the electromagnetic spectrum is essential for understanding the different types of electromagnetic waves. This is frequently tested in your examinations. Now, let me explain radio waves. Radio waves have the longest wavelength in the electromagnetic spectrum. Their wavelengths range from about 1 millimeter to 100 kilometers. They have the lowest frequencies. They are produced by oscillating charges in antennas. They are used for communication. Radio waves are used for radio broadcasting, television broadcasting, and mobile phones. They are also used in radar and navigation. Radio waves can penetrate buildings and travel long distances. They are reflected by the ionosphere, which allows for long-distance communication. Understanding radio waves is essential for understanding communication technology. This is a key part of the electromagnetic spectrum. Now let me explain microwaves. Microwaves have wavelengths ranging from about 1 millimeter to 1 meter. They have higher frequencies than radio waves. They are produced by special vacuum tubes called magnetrons and klystrons. They are used for communication. Microwaves are used in satellite communication and radar. They are also used in microwave ovens. Microwaves cause water molecules to vibrate, which produces heat. They are used in cooking. Microwaves can penetrate clouds and rain, making them useful for communication. Understanding microwaves is essential for understanding modern communication and cooking technology. This is frequently tested. Now let me explain infrared radiation. Infrared radiation has wavelengths ranging from about 700 nanometers to 1 millimeter. It is produced by hot objects. All objects emit infrared radiation. The amount depends on the temperature. Infrared radiation is used for heating. It is used in infrared heaters and toasters. It is used for night vision. Infrared cameras detect heat. It is used in remote controls. Infrared radiation is used in thermal imaging. It is used in medicine for physiotherapy. Understanding infrared radiation is essential for understanding heat and thermal imaging. This is an important part of the spectrum. Now let me explain visible light. Visible light is the part of the electromagnetic spectrum that can be detected by the human eye. Its wavelengths range from about 400 nanometers to 700 nanometers. It is produced by hot objects, such as the sun and light bulbs. Visible light is essential for vision. It allows us to see the world around us. It is used in lighting, photography, and optical instruments. Visible light can be split into its constituent colors. The colors are red, orange, yellow, green, blue, indigo, and violet. Red has the longest wavelength and lowest frequency. Violet has the shortest wavelength and highest frequency. Understanding visible light is essential for understanding optics and vision. This is a fundamental part of physics. Now let me explain ultraviolet radiation. Ultraviolet radiation has wavelengths ranging from about 10 nanometers to 400 nanometers. It has higher frequencies than visible light. It is produced by the sun and by special lamps. Ultraviolet radiation is used for sterilization. It kills bacteria and viruses. It is used in water purification. It is used in medical treatments. It causes skin tanning and sunburn. Overexposure to ultraviolet radiation can cause skin cancer. The ozone layer protects us from ultraviolet radiation. Understanding ultraviolet radiation is essential for understanding health and the environment. This is an important part of the spectrum. Now let me explain X-rays. X-rays have wavelengths ranging from about 0.01 nanometers to 10 nanometers. They have very high frequencies. They are produced when high-speed electrons strike a metal target. X-rays are used in medicine for imaging. They are used to see bones and teeth. They are used in dentistry. They are used in security screening. They are used in scientific research. X-rays can penetrate soft tissue, but are absorbed by bones. This allows for clear images of bones. Understanding X-rays is essential for understanding medical imaging. This is a key application of electromagnetic waves. Now, let me explain gamma rays. Gamma rays have the shortest wavelength in the electromagnetic spectrum. Their wavelengths are less than 0.01 nanometers. They have the highest frequencies and the highest energy. They are produced by nuclear reactions and radioactive decay. Gamma rays are used in medicine for cancer treatment. They are used in radiotherapy to kill cancer cells. They are used in sterilization. They are used in scientific research. Gamma rays are very penetrating. They can pass through thick materials. They are dangerous to living tissue. Understanding gamma rays is essential for understanding nuclear physics and medicine. This is the most energetic part of the spectrum. Now let me explain the production of electromagnetic waves. Electromagnetic waves are produced by accelerating charges. When a charge accelerates, it produces a changing electric field. This changing electric field produces a changing magnetic field. The two fields sustain each other. The wave propagates outward. In an antenna, alternating current causes electrons to oscillate. This produces electromagnetic waves. The frequency of the wave is equal to the frequency of the oscillation. Higher frequency oscillations produce shorter wavelength waves. Understanding the production of electromagnetic waves is essential for understanding how they are generated. This is a fundamental concept in physics. Now let me explain the detection of electromagnetic waves. Electromagnetic waves are detected by various devices. Radio waves are detected by antennas. The antenna receives the wave and produces a current. Microwaves are detected by special receivers. Infrared radiation is detected by thermal detectors and photodetectors. Visible light is detected by the eye and by photographic film. Ultraviolet radiation is detected by photodetectors. X-rays are detected by photographic film and electronic detectors. Gamma rays are detected by scintillation detectors and Geiger counters. Understanding the detection of electromagnetic waves is essential for understanding how we observe the universe. This is a key concept in astronomy and technology. Now let me explain the applications of electromagnetic waves. Electromagnetic waves have countless applications. In communication, radio waves and microwaves are used for broadcasting and mobile phones. In medicine, X-rays and gamma rays are used for imaging and treatment. In heating, infrared radiation is used in heaters and ovens. In lighting, visible light is used for illumination. In sterilization, ultraviolet radiation is used to kill bacteria. In security, X-rays are used in airport scanners. In astronomy, all types of electromagnetic waves are used to study the universe. Understanding the applications of electromagnetic waves is essential for understanding modern technology. This is frequently tested in your examinations. Now let me explain the importance of electromagnetic waves. Electromagnetic waves are important for several reasons. First, they allow communication. They enable radio, television, and mobile phones. Second, they allow medical imaging and treatment. They save lives through X-rays and radiotherapy. Third, they allow us to see. Visible light is essential for vision. Fourth, they allow us to study the universe. Telescopes detect electromagnetic waves from distant stars and galaxies. Fifth, they are used in many technologies, from microwave ovens to remote controls. Understanding electromagnetic waves is essential for physics and technology. They are fundamental to modern life. Now let me give you sample exam questions to prepare you for your test. What are electromagnetic waves? Electromagnetic waves are waves that consist of oscillating electric and magnetic fields. State the properties of electromagnetic waves. They are transverse, do not require a medium, travel at the speed of light, and can be reflected, refracted, diffracted, and interfere. List the electromagnetic spectrum in order of increasing frequency: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. What is the speed of electromagnetic waves in a vacuum? The speed is 3 × 10⁸ meters per second. State the uses of radio waves. Radio waves are used for communication, broadcasting, and radar. State the uses of X-rays. X-rays are used for medical imaging and security screening. State the uses of gamma rays. Gamma rays are used for cancer treatment and sterilization. How are electromagnetic waves produced? Electromagnetic waves are produced by accelerating charges. Let me summarize everything we have covered today. Electromagnetic waves consist of oscillating electric and magnetic fields. They are transverse waves that travel at the speed of light. They do not require a medium. The electromagnetic spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Each type has different wavelengths, frequencies, and applications. Electromagnetic waves are used in communication, medicine, heating, lighting, sterilization, and astronomy. Understanding electromagnetic waves is essential for physics and technology. This is topic 4 in your SS3 physics series. Study it well. It always appears in your objective questions. Well done.